All right, we're going to be working on the Module 1 assignment in this video, and we'll start by just kind of reading the description. So the point is to build a mortgage calculator. So we're going to get inputs from our user, convert them to the correct data types, and then use that data to calculate a mortgage payment, apparently. We're going to get and store inputs, convert the inputs to the correct type, and use expressions for calculations. So it says, get the following from the user: the total amount of the user's loan, the interest rate, the length of loan in years. All right, so this is, I don't know if you guys are picking up on this, super similar to what we already did with the Module 3 lab, right? So it's not much of a step beyond that, just a different formula that we're working with though. The following calculation should be done to get the monthly payment. And I want you to notice that in this expression, the carets represent exponential notation. So in other words, if this was written in traditional math language, a little n would be up here as a superscript, and then the n minus 1 would be up here as a superscript. And we're taking one basically exponential expression and dividing it by another exponential expression. And once again, these are equations that heavily favor the bank for sure. Alexis, question?
Yeah, it may just be another technical issue and it may be Zoom, but for me, and I noticed this last week too, with your mouse moving, it's not matching up with what I believe you should be. Like when you were explaining the equation, it was like on the way other side. I don't know if it's doing it for anybody else,
Same
but
here. It's like moving on its
Yeah,
own,
yeah,
like moving the mouse.
it's wandering all over the place.
Oh, really?
yeah.
Interesting.
Yeah.
I got the magic mouse, but not in the way I need the magic, apparently. All right. And of course, we're recording this and putting it out on the internet on top of it all. All right. Well, I think that's kind of an interesting effect. I have a little preview screen where I can see what it looks like, but I'm not seeing that effect. And I'm wondering if it's because I'm switching to screen number 2. Why don't we do this? I'll pause the recording for just a moment. I think we fixed our issues. But basically, we're looking at this equation, and our job, of course, is to convert it into a format that works for Python. Notice that all the letters in the equation have definitions, right? So M is what we're trying to ultimately calculate, which is what the monthly payment is. That's often the question that borrowers have when they take out a loan, like how much does it cost per month? And then we have the equation already spelled out with all the parentheses in the right spot. The biggest trick to converting this equation is basically taking the caret symbol and converting it to a double asterisk for Python version of exponential notation. One thing that I like to do here, though, is, and this is something that you guys might do as well, is when you're given information like this, it might be handy to actually kind of move it over into your IDE and have it there, because if we don't really need to tweak that formula a lot, we're most of the way there already. So why not just move that over and copy it as it is and try to follow even the letters that are provided for the monthly payment, the principal, interest, and the number of payments. I think that's pretty helpful. I have it highlighted. I'm doing a Control C to copy. And then I have it in the buffer basically ready to paste. We do have an example output here. So in other words, this is what they want the screens to look like. So they have kind of like a fancy little header here. Notice the ASCII art that's included with it, right? Little dashes and equal signs, and there's a blank line. Then there's 3 prompts, and then there are prompts to enter the information. So we'll prompt for a dollar amount, a percentage, and the loan length in years. And then we have some blank lines, and then we have an output of the monthly payment. So there's, inputs from the user, we're storing, converting to numbers, running the equation, probably storing that value, and then outputting it to the screen in a format that makes sense. Right? There's some tips and guides and stuff down here, but I think we have all the information we need to get started. So I'm going to go back over to Visual Studio Code here. I have a folder that's preset to put the assignment into. I'm going to use the my mouse here to highlight that folder to make sure that's the one I'm working on, and then I'm going to create a new file I'm doing it from the Explorer. You could also do it from here, whatever your preference is. But I'm going to do it from the tab here. I'm going to call this module 1 assignment. And if you wish, you could call it mortgage calculator. But I'm a big fan of not putting spaces in my file names whenever I write software. This is just an old school quirk of mine. And then I'm just going to name this module 1 assignment.py. That's my naming convention. You want to call it something else, that's on you. So the first thing I want to do is, well, they want me to put that like fancy little mortgage calculator banner up on the screen. Yes, I have it pre-prepared here on screen number 2. So I'm just going to copy and paste that in. Right, so there's my little ASCII art. One thing we didn't really talk about a lot last time is this is technically called an escape sequence, and it adds a blank line to my program. So that would be equivalent to having a blank print statement, if you will. We haven't formally talked about that, but we will talk about this. Next step in the program is to prompt the user for input. And as I often do when I'm like kind of coding a program, right, is I'll sometimes put that in as comments and kind of to reinforce a couple of different things. A real typical pattern for software development, by the way, is you have inputs for your program, then you process whatever information, you do whatever logic is necessary, and then you output some sort of result to the user on the screen. And that's, I'm basically labeling it here so you can see it. So we know there's 3 prompts. We know what the verbiage of those prompts are. So I'm going to drop in the first one. I'm going to drop them in one at a time. So first, I'm going to store the principal amount, right? And notice I'm prompting with the input function, and then I'm converting it immediately to a floating point number, storing it in this variable. Now, I could change the formula, like if I don't want to use principal, whatever, I want to match the letters from the example, but for right now, that's where I'm storing it. I also want to grab the annual interest rate, and notice that when I did this one, and this is a thing that's happened in modern programming. In the old days, when we would capture stuff and store it in a variable, we'd sometimes be capped at the number of characters that we could use. Like, and I don't remember if it was Pascal or Basic or one of those languages I learned way back when, where I think you could only use 8 characters or something like that to name a variable. In modern programming, and Python is one of those languages that really pushes this, is name your variable really verbosely and name it what it is. So don't call it like A or R or something like that. I'm calling it annual interest rate. I'm spelling out the whole darn thing. Now, some of you are going, well, the formula on the other page uses single letters. Don't you want to do that? I'll show you. I will get there. Right. Just want to show you the process of it here. We're also prompting them for the number of years. Notice this one I'm leaving as an integer. That's on purpose, right? Because I don't want somebody typing, well, I want my loan length to be 30.25 year, whatever. They're not going to do that. We set it to a certain amount. All right, so that's our inputs. The next thing that I did is I did grab all that data that was given, right? And I'm just dropping it in here just as reference. It is non-functioning, but it's there right in front of my face, so I can refer to it, think about it, not have to flip screens to look at the information or find it. It's just easier to look at it here. I don't have to leave it here, but I'm probably going to. I'm just telling you that up front. Now, at this point, we're going into what I'll call the processing of the program. So there's input, process, output, right? So we're going into the processing. The first thing that I'm going to do is I'm going to do some really simplistic math. So I'm going to take and divide the year by 12-month increments on purpose, right? I'm also going to multiply the interest rate to get a percentage. And if you start to think about that, so in other words, I'm trying to get the interest rate for what it is monthly. This is the conceptual leap in this program, by the way, and this is the part some of you might have missed. But if I have an annual interest rate, but it compounds monthly, and this is exactly how home loans work, by the way, is every month the interest accrues. Unlike a credit card, like if you have a credit card, like a Visa card or something, and you carry a balance on it, that interest accrues daily. So what they do is they take whatever your annual percentage rate is, and they figure out how much that interest rate is per day, and they add it to your credit card bill. That's why credit cards are really that deal, right? Because every day they add interest. With a home loan, the interest is added monthly. Every month interest is added, but the days in between, interest is not added. So if I'm taking a percentage rate, so let's say somebody types in 5 or 5.5% for their mortgage rate. If I want to figure out what that interest rate is per month, I got to divide it by 12, right? So I'm just going to kind of give you like a what if here, right? So I would take, the annual rate, I'm abbreviating here, and I would divide that by 12. But keeping in mind that somebody typed in for the annual rate 5. Well, I still got to multiply that by 100. So I would also take the divisor and multiply it by 100. And if you do the math on that, it works out to 1200. Right? So this is where my formula is coming from, if you're wondering. So the way that I'm going to do that is I'm going to take the R in the equation that we see. Right. So I'm taking the annual interest rate they typed in. I'm dividing it by 12 and multiplying by 100. We already know that's 1200. So I'm dividing by 1200, same difference. And that's giving me the interest rate monthly that works in that equation. All right. The next part is I want to also take the years, right? Because if you've got like a 30-year loan on your house, but your payments are monthly, well, I got to take those years and multiply them by 12 to get the total number of payments. So N is the number of payments. So for N, I'm going to say years times 12. So there's the conversions to the letters in the formula. All right. Now the principal loan amount, well, okay, I did that with a capital P, but if you look at the equation that sits out in front, so that's not a big deal. I'll just use the whole name on it. If you're not comfortable with that, you can convert that to a P or a capital P or whatever you want. That's on you. So here comes the calculation. So this is still part of the processing, right? But I'm gonna label it, right? So calculate the monthly payment, and I'm gonna take that equation, right? And I would literally copy that, right? I've already done the work on it though, so I'll show you what I did here. So this is the result, and I know you guys are probably racing to screenshot it, but I got the principal, which is the P, right? And then the R that I converted up here. And you notice how I'm basically replacing all the stuff. The real difference is that caret symbol becomes a double asterisk. Right? Also notice that I put a multiplication here in front of the parentheses. What I do like about Visual Studio Code, by the way, is it color codes the pairs of parentheses so you can see what matches. So yellow holds the whole thing. Then we have our divisor, which splits the equation in two. The top part of the equation, right? And it's all following the order of operations that's declared here. We assume it's correct, right? It's a given formula. And we just convert it. So there's the complete statement right there. So assuming that formula is correct, and I know it is because I tested it before, then we go to the output. So we do input, right? So these are our inputs. This is the processing, just a few equations. The user doesn't see this stuff. It happens in the background. And then we do the output. For the output, I followed the same format we did in lab number 3. So I did a string interpolation with an F string or whatever you want to call it. And the monthly payment is declared right inside the statement with a 0.2F to format it as money. Now we are given sample amounts, so I'm going to put in the values that they indicate here. So 300,000 at 5% for 30 years, and it comes up with 1610.46. Let's see if it works. That's really the true test, right? So here's the run. I'm going to do a Control S to save, hitting the run button. So it was 300,000. Oops, I gotta make sure I'm not up there. I'm down here. Click in the console to make that active. So there we go, 300,000. The interest rate is 5. And really the prompt should say, what's the annual interest rate? And then the length of the loan in years, which is 30 years, very typical. And your monthly payment is 1610.46. And the answer to the question that just popped up in the chat, the .2f takes that floating point number and converts it to 2 decimal places. It truncates it at 2 decimal places. If you want to experiment, and here's a good experiment, you could run this without that in there. I don't know if it would give us the same response. It might, but actually it doesn't. So notice what the actual output is. See that? So that's what the .2f does. So back up here, I'll Control Z that, put it back, and Control S to save. But folks, that is the solution for this exercise. So I'm going to stop the video here, and then we can talk about it.